This is generating 100,000 stories and collecting statistics on the use of different bits of content in them. We're going to let that run in the background while I talk to you about the programming language it's written in. All right. So this is a programming language for text generation. I'm not going to be able to teach it to you in 15 minutes. So what I'm going to do is I'm going to violently wave my hands through some simplistic examples to at least give you a sense of why you might want to read the paper, maybe even use the system, and also believe my take-home messages, which are that we spend a lot of time sort of implementing subsets of this over and over again. How about instead we do a maximalist implementation of it, have it be a nice programming language you can use for scripting, and also don't be afraid of unification and backtracking stuff. All right, what do I mean by text generation? I mean, you are making your indie AI-driven narrative game. Sooner or later, it needs to print something. The something it's printing is almost certainly human authored, but you need to do some kind of intelligent adaptation of it, generating pronouns, varied word choice, things like that. Why are you not working anymore? There we go. Okay, so all the techniques for this exist in an inclusion hierarchy. Fixed strings are a special case of templates. Templates are essentially a special case of context-free grammars. They're just recursive templates. Context-free grammars are a special case of definite clause grammars, which are essentially context-free grammars with parameter passing and pattern matching. And for our purposes, shop-style HTN planners, or definite clause grammars are a special case of HTNs, which add the ability to have mutable state that gets tracked throughout the execution. And that's a special case of higher order HTNs, where you can have tasks that are parameterized by other tasks. And so my argument is just implement the full version. These are really all one evaluation strategy. All of these things use the thing you learned and forgot in your undergraduate AI class, where you do and/or tree search, chronological backtracking, and unification. So let's just do that. So STEP is a programming language for text generation that implements a well-engineered maximalist version of that, and that's trying to be writer-friendly. My goal is for theater majors to be able to use it. My goal is for my friends who are novelists and tabletop game designers to be able to build PCG systems with it. Come on, you can do it. All right. For my own practice, it's sort of my version of Python. It's the quick and dirty scripting language that you can use for trying things out and experimenting. It's open source, it's a DLL, you can drop it into your Unity game or any other .NET thing. Main features of it: pattern-directed invocation a la Prolog based on unification. It's a full non-deterministic language, including mutable state. And so you can have variables that you change the values of, and objects that you change the slots of. And if the system needs to backtrack, it does the right thing, and you don't see the effects of execution paths that you've abandoned. And it also adds the stuff that you actually need for games, like weighted random shuffles and cooldowns and things like that. The higher order language, it's homo-iconic. It implements static reflection so that programs can reason about their own structure, and dynamic reflection so that if you're in some path of the search tree, you can ask, how did I get here? Come on, you can do it. All right. Has good tooling. There's a read-about print loop, interactive debugger with stepping, stack display, all that stuff, syntax highlighting, simple unit test framework, simple support for profiling, which we're going to see in a minute. So now I'm going to try and give you a sense of the language through examples. If you just want to print some text, name a procedure : text you want to print. If you want to fill in variables inside of a template, just put in the variable, it will print it. This is the one slide that uses up arrow rather than a question mark. Happy to talk to you offline about what that distinction is. You don't need to know. Context-free grammars are simply templates that can call other templates. How you call something, you just put the call in brackets. And so this says a greeting is a salutation followed by a comma, followed by a name, where a salutation is one of these randomly chosen, and a name is one of these randomly chosen. Definite clause grammar is a context-free grammar with variables and pattern matching. And so now we have the same thing, only rather than randomly generating a name, it's passed in as an argument. And now we have the ability to have a special purpose rule for Donald because everybody hates Donald. Now here's the thing. The execution strategy that you use for this is the same execution strategy you use for logic programming. So we can use this same engine for logic programming. And in fact, the underlying engine has no idea whether what it's running is a grammar rule or logic programming or something more complicated than that. As far as it's concerned, logic programming stuff is just rules that don't happen to print things. So we can give it a table of dogs, cats, and their humans. Then we can have a rule that says a human has a cat if they have a cat and a cat, and then if you call that with a particular human, it will either succeed or fail, provided they have that, they have a cat. And if you call it with a variable, it will randomly choose a human with a cat. And if we backtrack over that, it will systematically cycle through all the humans that have cats. We can then use logic programming expressions as guards on things that generate text. So we take the same greeting example that we had before, add an extra rule that says, oh, if they're a cat owner, then ask them how their cat is. I like cats. Variable printing is actually just syntactic sugar for a call to a task called mention, which the system gives you a default implementation of that just prints its argument. But if you want to, you can rewrite that with whatever you want. So let's say you want to generate Japanese honorifics, and you have a representation of the knowledge necessary to understand the social relationships between your characters, then you can generate senpai and kohai and all of that simply by redefining mention. All right? If you want to do pronoun generation, then you need state variables for the current reference of the different pronouns. You have one set of rules that track when you're trying to print the current referent of they, it just prints the pronoun. And another set of rules that do a case analysis, print out whatever their argument is, but update the relevant global variable. Sebastian Perez Delgado, one of our undergrads, did a story sifter for the commercial game City of Gangsters. And so this is a rule for generating obituaries for a kind of imaginary newspaper that says, if P is a dead person with a child who hasn't died yet, then vomit forth this text filling in all of the vital statistics about the current child. You're not going to use this to write a real planner like Sabre, but you can do some simple things like you can add, in the form of a predicate, a table of, for any given goal, what task can potentially achieve it, and then write a task called achieve that takes the goal, looks up the task that achieves it, and runs it. Except, of course, you also first wanted to check to see if it's already been achieved, and you want to do some loop detection to make sure that you don't get caught in event recursions. One of the marquee features of the Expressionist system of James Ryan's is that it's context-free grammars, but it's context-free grammars where you can tag rules with strings. And then the system reports back to you what tags got used in the actual derivation you got. I think the later versions let you say, give me a derivation that uses this set of tags. We can implement tagging just by saying a tag is a procedure that doesn't do anything. Then you can sprinkle your rules with calls to that. And then you can use reflection as a way of asking, hey, I've gotten all this way on the search path. How did I get here? Did I, in the process of generating this greeting, run tag forward? If not, this call will fail. We will generate another greeting, and we keep doing it until we get a formal greeting. We use the same trick to do profiling of a story generator. So if we have a tag called beat that we add to all of our tasks that are story beats, then we can write a predicate story beat that takes the task and tells you whether or not it's a story beat. And then there are built-in procedures, call counts. This says, make a story, look what beats were used in it, run it 1,000 times. We're actually just ran it 100,000 times. And then give a table of how often the different beats get used, so that if you're overusing something, you find out. Similarly, you can run it and find out what are the beats that never got used, because that's an indication of a bug. All right, evaluation. So I'm going to try and evaluate this with two proxies. One, I'm going to use code size as a proxy for programmer effort. So I went and I re-implemented my own game, Dear Leader, Happy Story Time, in Step. The Step version is 35% smaller than the original Prologue version and implements more functionality. It does things like pronominalization. In terms of like how much effort is it to build Step, that's really hard to determine, but I did compare it to the size of Expressionist. So Step, the interpreter is about 12,000 lines. The IDE support is another 2.5, I think it is, or 3.5. And Expressionist is 73,000 lines. I'm guessing a lot of that is various people's JavaScript libraries that just got thrown in. I assume that James did not actually write all 73,000 lines. But suffice it to say, I think I can make an argument that I'm not paying a price in terms of implementation effort for having just gone out and built the maximalist thing. I'm going to use, and maybe this is just my personal hobby horse, I'm going to use number of punctuation characters as a proxy for code readability. So
you're missing a parenthesis though, that's going to count.
Oh man. We can talk about that offline. Oh, you're right, I am. Okay, so here's the Prologue version from Dear Leader, which has 21 characters. Here's the Step version, which has 9 punctuation characters. I don't know whether this slide is persuasive. I do think that if you look at the real source code for both systems, you will find the Step version looks more like writing and less like weird AI. There is a longer, more worked out annotated example in the appendix to the paper, which is a Step implementation of the dice-based generator from the commercial tabletop RPG, I Hunt Killing Monsters in the Gig Economy. I'm now working with the authors of that, Olivia Hill and Philomena Young, to let them write their own much fancier PCG system for the game, coming soon to an iPhone or Android phone near you, I hope. So that gives me the opportunity to, try and teach it to real game designers. All right, I stand on the shoulders of giants. Here are my take-home messages again. And there. And here are our statistics from 100,000 stories about the beat frequency for each beat in the source. All right, question.